hypothesis testing uses sample data from the population to draw useful conclusions. Regarding the population probability distribution, it tests an assumption made about the data using different types of hypothesis testing methodologies. The hypothesis testing results in either rejecting or not rejecting the null hypothesis.
It is a tool for making statistical inferences about the population data. It is an analysis tool that tests assumption and determines how likely something is within a given standard to accuracy. Hypothesis testing provides a way to verify whether the results of an experiment are valid. Here is the sample mean. Is the population mean is the standard deviation and is the sample size.
Good morning, Sir KJ. Today I will discuss about the types of hypothesis testing. So there are 4 types of hypothesis testing, but I divided it into 2 types. So the 2 types of hypothesis testing is the null and the alternative hypothesis. And the other types of hypothesis testing is the right-tailed, the one-tailed, and the two-tailed test. First, we discuss about the 2 types of hypothesis testing, which is the null hypothesis and the alternative hypothesis. So, what is a null hypothesis? A null hypothesis is a type of statistical hypothesis that process that no statistical significance exists in a set of given observation. Hypothesis testing is used to assess the credibility of a hypothesis by using sample data, sometimes referred to simply as the null, and it is represented by HO. And the alternative hypothesis, which is represented by HA, this is also known as the claim. The null and alternative are always claimed about the population. That's because the goal of hypothesis testing is to make inferences about a population based on a sample. Often we infer whether there's an effect in the population by looking at difference between groups or relations between variables in the sample. It's critical sa the average age of all students in a city is 23 years old. Since this hypothesis contains equality, we refer to it as a null hypothesis represented by HO. So our mean would be HO mean equal 23. The complement or opposite of the null hypothesis is the alternative hypothesis, represented by HA or H1. In this case, the alternative would be that the mean is not equal to 23. We use this hypothesis in total because the alternative basically is that the mean would be less or greater than 23. Now, what if we want to test if the mean is less than 23? Since this statement does not contain equality, we will assign it to the alternative hypothesis and the null will be the opposite, and that is the mean is greater than or equal to 23. Now, if we want to test is the mean is greater than 23, that would be the alternative hypothesis and the null would be mean is less than or equal to 23. This too is an example of one-tailed test.
State the hypothesis. First and foremost, we need to state hypothesis. The null hypothesis H0 and the alternative hypothesis HA. The null hypothesis is the one we are testing, while the alternative hypothesis is accepted when the null hypothesis is rejected. We can calculate the hypothesis in 3 ways, depending on the population's parameter 0 and the relations to a possible value 0, 0. Null 0, 0, 0, alternative 0, null greater than 0. Consider the alternative hypothesis is the one suspect to be true or wish to prove. To prove it, you need to reject the hypothesis. Example, suppose you suspect a fund's performance beat the benchmark 0. Represents the performance difference between the fund and the benchmark. You want to prove that 0 greater than 0, so you make it your alternative hypothesis HA. The null hypothesis H0 is its complement delta.
Step 2. Identify the test statistic and its probability distribution. The test statistic is the basis for rejecting the null hypothesis. Its general form is calculated as statistic. Issue value is standard error of the sample statistic. Now, we need to determine the test statistics probability distribution. In the curriculum, we'll discuss for distributions Z, T, square, and F distribution. For now, let's use the T distribution. In our example, we collect 30 random observations of the mutual funds outperformance data. The degrees of freedom in our example are 30 minus 1 equals 29.
Step 3. Specify the significance level. Since hypothesis testing involves making inferences from sample statistics, there's always a chance of error. There are two types of errors. Type 1 error, rejecting the null hypothesis when it is actually true. Type 2 error, failing to reject the null hypothesis when it is actually false. The significance level is the probability of making a type 1 error, while the probability of making a type 2 error is denoted by beta. It's challenging to quantify beta, so we won't cover it in this lesson. The power of a test is the probability of correctly rejecting a null hypothesis.
The decision rules involve determining whether the test statistic is current to fall outside the critical value if is those the result is statistically significant and we reject the hypothesis.
For our example, we perform a one-tail test on the right tail of the distribution. Based on the null hypothesis, we expect the simple mean to be near or less than 0. If the test statistic falls within this region, it is statistically insignificant wherever it is false in the right tail. It is statistically significant, and we reject the null hypothesis using the distribution with 29 degrees of freedom. We find the critical value of 1.669 for a one-tail level of 0.05. We reject the null hypothesis of if the test statistic is greater than 1.699.
Step 5. Collect the data and calculate test statistic. It's crucial to ensure the quality of sample to minimize the probability of flawed conclusions. Make sure the data is free from measurement errors and biases from sample selection. Be aware of time period bias and affect the starting ending dates on the conclusion drawn from the sample. In our example, we collect 30 random observations of the mutual funds outperformance data. We find that sample mean is 4.5% with a standard deviation of 12%. Thus, the test statistic is calculated to be 2.0. Step 6. Make the statistical decision. In our example, the statistical falls within the rejection region T greater than 1.699, so we reject the null hypothesis. We conclude the mutual fund dose outperform the benchmark at 5% significance level.
Make the economic decision. Statistical difference doesn't always imply economic significance, and analyze should consider another function to determine if the strategy is the economically advantageous. In the end, always remember to weigh the statistical findings with real-world context and implication before making a final